So we recently shipped our first grid code in production, and I'd like to make a quick retrospective on what was good about it, what was challenging, and basically how grid can help you solve your layout requirements. But first, let me quickly introduce myself. I'm a UI designer and front-end developer. I work at Stripe, and for those of you who don't know Stripe, we basically do online payments the right way. So, we've recently updated our site logo type and visual language. The goal was to improve the structure and the content, to refresh the brand by making something unique and visually interesting, and to create a set of patterns that would contribute to build a strong identity. And part of it relies on these new tilted backgrounds made of multiple stripes, as we obviously call them, and that you can find on all these new pages with a slightly different treatment. We also introduced a whole set of new animations and interactions, which apparently inspired some sites. Anyway, so we use all these animations and patterns to create a consistent look and feel across the site, which means we often tweak these patterns to accommodate the various styles of the pages. So here on the Connect page, for example, the header stripes in the background almost look like light rays coming from the sides. And I'd like to take a moment to analyze how we made them. Okay, so first I've removed all the content so we can really focus on the background and try to understand how it's built. So the whole background is actually just a big grid container that's transformed using a skew function. So if you use the grid inspector in Firefox, we can clearly visualize the grid. We have 5 rows and 10 columns, and we just tilt the entire thing by 12 degrees. I'm also going to disable that rotation for now to make the structure even easier to understand. So we can now clearly see this big grid where we can conveniently place as many stripes as we want, exactly where we want. So using the inspector again, I'm just going to highlight 3 stripes placed on the grid. For example, I'm just placing the first stripe on the first row, and I simply make it span 3 columns. And then the same principle applies to the other stripes. I can then just apply a background gradient on all the stripes to create the lighting effect, and I'm basically done. So if we look at the code, it is now a lot easier than what we used to do. So first, the markup, super simple, is just a div and a bunch of spans representing the stripes. Now, for the CSS, it's just a matter of defining a template grid and placing each span individually in the appropriate rows and columns. So on the parent, we use the grid shorthand property and the repeat function to easily define 5 rows of 200 pixels and 10 columns of 1 FR. So the FR unit I'm using here represents a fraction of the available space. So in this case, it's exactly the same as using 10%. And then for the child elements, we just explicitly insert them in the grid. So as we can see from this specific example, grid comes with many different properties and shorthands. And while you could always use the same syntax for everything, relying on the appropriate shorthand or property or long-form property makes the code shorter and more expressive. So, for example, grid area lets you define the start and end values for both rows and columns into a single declaration. So that line means start on the 3rd row, span 3 columns, end on the next row and on the last column. So this last value I'm using here, -1, is super useful in grid as it allows you to count in reverse, which means you can cover an entire track without knowing the exact number of rows or columns. So that was for placing all the stripes in the grid background. And now that all the positioning is done, the last thing to do is just to skew the entire background. So to do that, we just transformed the entire grid container to create a tilted effect, and we give it a background gradient. And that's all. So compared to what we used to do, this is a lot nicer. And to be clear, it's not just easier to code, it's also a lot more robust and maintainable. For example, our previous implementation relied on position absolute, and that led to many subtle visual flows, like a 1 pixel gap between two stripes caused by a slightly different rounding on 2 percentages. So just by using grid instead, we avoid a whole bunch of issues. And additionally, the grid implementation makes it a lot nicer to build a responsive structure. So here, for example, we have a mobile-first approach where we define 5 columns by default, and then when the viewport is wider than 1,000 pixels, we update the template to define 10 columns instead by simply increasing our custom property inside the media query. So that's both super convenient and super efficient, and it allows you to dynamically change the design significantly with just a few rules. So that's one use case where grid really shines and proves to be a much better solution than any other method. And the more you use grid, the more you can see how it can elegantly solve many tricky layout issues. So for example, this is another use case where grid made a ton of sense. So we have this structure with a small introduction, a paragraph, and then a bunch of animated charts illustrating the various flows Stripe Connect enables. So if you use the grid inspector again in Firefox, we can see that the whole thing is just a big grid, and we can clearly visualize the gap and grid tracks. And the part I want to focus on is this specific area where we have 2 elements in the same cell. We have the pattern in the background and then the chart above it. So these are 2 separate elements because I needed to move the chart left and right during the animation without moving the background with it. And that's another thing that grid makes super easy to do. So we have a simplifying markup at the top and then the styles at the bottom. So on the parent, I just define my template grid, which has a fixed column of 340 pixels, a fluid column, that takes the rest of the available space, and then a gap between these 2 columns of 40 pixels. So the gap shorthand property I'm using here is basically the same as the previous grid gap shorthand property, but which is now also available for flexbox and multi-column, so it's kind of a big deal. Anyway, so after that, I just select my 2 elements, which both have an ID starting with diagram, and I just place both of them in the exact same spot by forcing both of them to start on the 3rd row and 2nd columns. So this is effectively a replacement for position absolute. You don't have to take elements out of the flow anymore. Just place them in the same grid area and you can stack them easily. And that means you even have access to Z-index. So if for some reason I wanted my background to be above the diagram, I could simply give it as an index. And to be clear, that's not just a nicer way to stack elements. You can do many things with grid that position absolute simply cannot do. For example, with grid, you can center all child elements horizontally and vertically, even with variable widths and heights, and all of that in literally 1 line of CSS. So in case you're not familiar with the place items property, it's a new shorthand property for align items and justify items. And if you only specify 1 value, in this case center, it's just going to use that for the missing value. So that's super convenient, and you obviously have the same thing for align content and justify content with the place content shorthand property. So as an example, say you wanted to stack all the elements in the center of the body. Well, you could simply place all of them in the same cell and center them automatically no matter their sizes with place items center. So as we could see so far, most of the work in grid is done by the container. So instead of dealing with each element individually for their positioning, we do almost everything right from the container. And that is a crucial difference between grid and other layout methods like Flexbox, for example. So to illustrate that, let's take another example from the same Connect page. So we have here 3 columns with an icon, a title, and a paragraph. If we highlight the grid, we can see the gaps, rows, and auto columns that have been dynamically generated to accommodate the content. So usually, this structure used to require some extra markup to wrap the content of each column in order to display them side by side. But with Grid, that's not even necessary anymore. Since the structure is now defined by the container right in CSS, we can keep a very clean markup without adding several wrappers only needed for the presentation of the content. So here, we only have the semantic markup actually needed to describe the content, which means we have a very flat and a very simple structure. As for the CSS, we don't even explicitly place our content in the grid here. We simply let the content flow into the template rows and auto columns defined by the container. So the autoflow keywords means here that we fill the grid by columns instead of rows, and that each generated column is going to take the same fraction of the available space. So in this example, after the third element filling the first column, it automatically creates another column of the same size, and it keeps doing that for the next elements. So that illustrates how in Grid, most of the work is done by the container and how your markup isn't really dictated anymore by your presentation needs. Now, if we come back again to our initial markup, you might be wondering how you're supposed to create a fallback for all the browsers that don't support Grid with such a minimal markup. Because in order to create these three columns with flexbox or float or whatever, you really need a container element for each column. So you're probably going to do something like this. Now, the previous CSS Grid code won't work anymore if we add these new div wrappers. But it would be really unfortunate to change our grid logic just because of some temporary fallback needs. So instead, what we can do is to literally ignore these wrappers right in the CSS Grid code. So thanks to display contents, these div wrappers will basically be replaced by their child elements. And so the initial grid will continue to work as if there was no wrappers at all in the markup. So that's really good, because if you eventually drop support for all the browsers, or if you write all your fallback rules after all your grid code because maybe that was not the priority for your target audience, etc., well, you don't have to change your grid logic. It just keeps working as expected. Now, we haven't really touched yet on how to create these fallback rules. So the typical way to handle that is to write your fallback rules first, and then to use CSS feature queries to override the fallback with new properties and values. Now, the obvious downside of that approach is that it forces literally everyone to download all these fallback rules that might be completely useless for the vast majority of your customers. And additionally, there's a good chance that even if you decide in the future you don't need all these fallback rules anymore because literally 100% of your visitors use a grid-friendly browser, well, I bet you won't feel like manually editing all your style sheet to see the code being shared between the fallbacks and the override, and to remove all the code that's not necessary anymore. So don't just make assumptions, check if featured queries are the right way to go for your target audience. But for us, it was crystal clear that this was not the optimal way of serving fallback rules. Our analytics made it clear we have a fairly technical audience, and honestly, almost everyone was already using a grid-friendly browser. So instead of using CSS feature queries, we chose to create a separate fallback style sheet in JavaScript and to insert it dynamically only if it's actually needed. We can't rely on the CSS.supports method because that might not be supported by a browser that actually needs the fallback style sheet. So we just check if the grid property exists in the style object. So to be clear, this approach is kind of a trade-off because it's going to be a little bit slower for browsers that actually need the fallback style sheet, but it's going to be a little bit faster for modern browsers as they only download what's truly needed. Additionally, all the fallbacks are completely isolated from the main style sheet, so we can just decide to stop serving fallback rules in the future if we want to. So it's really up to you to decide who you are optimizing for, but for us, that approach made a lot of sense. So that was a lot of technical details and maybe a lot of new properties and values, and you might be wondering if it's actually worth learning all this new stuff and potentially spending a lot of time writing fallback rules, etc. So my recommendation is, yes, take the plunge immediately, even if you're not comfortable at all with Grid. The Connect page we analyzed was my first Grid project, my first real Grid project. And while I knew the spec pretty well before, there is a huge difference between knowing and practicing. And it's only after shipping a real project in production, you will really understand the value Grid brings to your layouts. And I can guarantee it's going to be a breath of fresh air in your front-end journey. So enjoy, and thank you.